Good morning. Today we're going to be talking about Math 3 Unit 7, Lesson 7.5, where we'll be translating parabolas from the origin. And so far in our unit, we have always had parabolas that had a vertex on the origin. We've been focusing on what the definition means. The definition of a parabola, remember from our very first day of exploration, was that it's the set of all points equidistant from a given point and a given line. And we explored with what that definition would look like, and we used the distance formula to really get a feel for equidistant and how that played, and then we derived the equation of the parabola. In the last couple days we've talked about different forms of the equation, and now I want to raise the question, how could we move the center off the origin? Because so far every parabola has a center on the origin. And remember, the definition was the set of all points equidistant from a given point and a given line. So you might ask them, do you think that definition means that all parabolas have to have a vertex at the origin? And my answer would be no. We've seen lots of parabolas that vertexes aren't at the origin over the course of the year. And so what would we need to do to the focus and directrix to move that off the origin? Now I'm going to point out to you that I originally had planned to first start with what would we do to the equation, and then what would we do to the focus and directrix. But as I practiced through those notes, I decided that I really like starting with this. What would we do to the focus and directrix? That keeps the emphasis on moving from the definition to the equation, which is one of our standards that we're working on. And then from there, I talked about what would that do to the equation. And that was kind of a nice wrap up and connect to previous things. When I was doing it in the opposite order, what I found was I started wanting to make all these connections to previous things, and we hadn't really set the idea yet, and it just felt a little bit more confused. So I'm going to explain it in this order. You are welcome to explain it in whichever order you prefer, but that's what I found. So I'm going to start with a little review. That's how I decided I wanted to talk to my students about how did we make the parabola face up? How did we make it face down? How did we make it face to the right and to the left? And so when we had it face up, you need to decide which form you're using, but I chose to use the focal width form. And so when it faced up, it had an x squared, and this 4c right here was a positive, and the focus was up here, and the directrix was a horizontal line. Down, it had the same kind of equation with the x squared by itself. It's just that this 4c was a negative then. And to be able to have that happen with the focus and directrix, what we needed was the directrix to be on top and the focus to be underneath, and that would make it face down. Then we talked about right and left, and facing right was when we had the y being squared. And the right facing parabola had this little 4c being positive, and so the focus was maybe over here somewhere, and then it's over here somewhere, and that made a parabola that faced to the right. And then to the left was also a y being squared. Do you know what I did wrong here? That's what I would ask my students. Hopefully you know. This should have been a 4cx, correct? Yes. The y is squared, the x is not squared, just like this one. And so on this, the 4c should be negative. To get that to face to the left, we'll need the focus to be over here and the directrix to be over here. And that would be a parabola then facing to the left. And I probably would draw in all my little parabolas. That's a nice kind of review, set what we've talked about already before we start messing with them and moving where the vertex is. Because these vertexes don't have to be at this point. Matter of fact, you might start with this as the review and say, well, do you think the vertex has to be at the origin, or is there a way to move a vertex of a parabola off of the origin? We definitely know that there is, because we've seen lots of parabolas like that, right? And so the question is then, how could we move the vertex off 0, 0? How could we translate it somewhere else? So what could we do to the focus and directrix? So here's how I would start. If the directrix is down here at y equals, what do I have, -2, right? But I don't want the the vertex to be 0, 0. Maybe I want another point. I'm going to just randomly pick that I would like my vertex to be there at 2, 1, right? Where would I want to put my focus to make that happen, to make my vertex be at 2, 1? And so I'm going to think about that this vertex has to be equal distance from the directrix and from the focus. And so if I want to know how far it is from the directrix, I have to go straight there, perpendicular to the directrix. And in this case, that's 1, 2, 3 away. And so now for the focus, I need to go straight there on the other side, 1, 2, 3, and that will be where the focus is, right? This is also 3. And so here's my focus. In this case, at a directrix of y equals -2, and it looks like visually that our focus should be at over 2, up 1, 2, 3, 4, and that will maybe make our vertex be where we want. That's what we're thinking. And then if we found points that were equal distance from that focus and this directrix, remember one of the easy ones that we found to make to go straight across from the focus. And so if I did go straight across this way, let's see, how far would it be up to that? Let's see, this was 3 and 3 was 6, so it would mean I was going up 6 right here. So I need to go over 6 from the focus to find that point. So let's see, 1, 2, 3, 4, 5, 6. So maybe right here would be a guess of a point that would be on there. It doesn't look right because my spacing on my axis is not good, so that's a good reason to maybe use graph paper. Again, this is a nice graph as to put up as a teacher because it's really big, kids will be able to see. If you just want to take this from 7.3 and edit that out a little bit, you can use that graph for your instruction. But so that would make equal distances, and that would be a point that was on there. And then we know that we should be able to go to the other side 6, 1, 2, 3, 4, 5, 6. And that would also be 6. And so we would end up getting a parabola with a vertex that was off of 0, 0. So it just would mean that things aren't really even in terms of the numbers, but they're still even in terms of the distances, 3 away, 3 away. And so you really need to look at the distances to be able to tell. So the question is, what would that then do to the equation? What would the equation look like if we wanted to put a focus up here and the not right on the y-axis? What would that do to the equation? And so remember that our definition is that from P to F has to be the exact same distance as P to D. Now let's get a random point P. So I'm going to put P over here. And we'll call that XY. And from P to F, that should be the same distance as from P down to D. Remember, you have to go straight down. So D, I wish I'd used a different color for that, but let's just do that now. D would be, let's see, over, I went straight down, so it should be over the same amount that this one was over, so it should be over X, and it went down exactly to -2 because all the y's on the directrix are -2. So I have P, X, Y, F, 2, 4. These would be the points I would be using to set up my distance formula, and we'll just try that out. PF, so here's from P to F. Call on a student for that, and I would have the distance between the x's, x minus 2 squared, plus between the y's, y minus 4 squared. My y's and 4's are a little tricky usually. And then from P to D, I also need that distance to be the same. And so I'm going to go x minus x squared and y minus -2 squared. Now I know that I am going to want to be able to work this all the way to the end and then have room to make notes on this later after I finish this, and so I'm going to go to another page. If I didn't write so big and skip so many lines, this definitely fits on one page when I did it originally. I'll show you, I had it on fine paper that fit just fine, but just as a teaching note, I wanted everybody to see everything, so I just have that redrawn, and so I have it here. So here's our PF equals PD, the same equation we were just at, and we're going to work that out and see what we get. So the first thing I want to do is square both sides. And when I square both sides, I'm going to lose the square root. I'm going to take my time on this and not FOIL these out because the students don't really know what's going to happen. And I want to show you a spot where we need to think. I will say, hey, that's just 0. I'm not going to bother with that. And this one will turn into, I can't help it, the teacher part of me wants to do that, will turn into y plus 2 squared. Okay. At this point, it's a good point to have your students think for a minute because we can FOIL all these out, but the reason we are going to, I shouldn't say FOIL, we can multiply all those out, but the reason we want to multiply is to find things that will cancel. And so these both have y's. Here's where things might cancel. This is not something that's going to give us anything extra to cancel. An important part of surviving this homework assignment is for them to not multiply this out. We haven't really talked about how they complete the square in a parabola, and so they'll get to a spot where they're stuck if they multiply this out. So they need to think right here what to multiply out. Okay. And so in this case, these two look like they're possible things where something might cancel. I am going to leave this one squared. When I multiply that out, I'll get y squared minus 8y plus 16. And when I multiply this one out, I'll get y squared plus 4y plus 4. Now, if I go to subtract the y squareds from both sides, I'm going to lose those. But nothing else is going to completely go away. I'm going to leave the squared by itself. I'm choosing to use the focal width form, so I'm going to leave the squared by itself. And I will add the 8y over to the other side and subtract the 16 over from the other side. And when I do that, I will have x minus 2 squared equals, and this adds up to 12y, and this subtracts to negative 12. Now, here's another spot that students often get stuck. Right here, we should be able to factor out the coefficient in front of y. So, and it should always happen that you factor the coefficient in front of y. If it's not going evenly, like this is beautifully going evenly, right? If it's not going evenly, there's one of two reasons that's happening. Maybe the vertex is a fraction, or maybe you have made a math mistake somewhere in here. I made a math mistake earlier today and I accidentally added 16, and guess what? That didn't factor out well, and it made me stop and think, and I realized I made a math mistake. So it's possible for a vertex to be on a fractional spot, but it's also very possible they made a math error. So if they get something that's difficult to factor out, think about, did they do any mistakes? Okay, what we have here now is really similar to the form that we had before. Before we had x squared equals 4cy, and now we just have a little bit of extra pieces. And what I want you to notice about that is our vertex up here in the original was over 2 up 1. Now, vertex in the original was over 2 up 1. And right here I can see that if I change the sign just like what we were doing before, that I would have a vertex that was 2, 1. Change the sign, change the sign. It matches very much to what we did before. My width of my parabola would be 12. I'd have 4c equals 12, and that would make c equal 3. Let's check and see if that is really true. Yes, in fact, this c here was 3. The distance in both cases was 3 from the vertex to the focus was 3. And so this is the other form. When there's shifting, is you will have those things moved in. Now, if you are going to work from vertex or descriptive form instead, then the extra steps for your students would be to get the not squared term by itself. So On worksheet 6, we're going to work quite a bit on that. On worksheet 5, the last couple problems do ask them to do that just to practice, but it's a main focus for worksheet 6. So you can decide how big a deal you want to make about that at this time. If you've been using vertex form the whole time, you'll probably want to go ahead and do the vertex form now. As a matter of fact, if I want to take this equation, let me just turn the page and write that equation again. So that equation was x minus 2 squared equals 12, y minus 1. And this was focal width form. And if I want to get that into descriptive or vertex form, focal width form, remember, always has the squared term by itself. Squared term alone. If I wanted to get that into vertex or descriptive form, I would want to get the not squared term alone. So the first thing I would do, you could distribute the 12, that would be totally fine. And the first thing I would do is divide by 12. And if I do that, I can have 1/12 x minus 2 squared, or multiply by 1/12. Maybe that would be easier fractionally for kids. And then I would have left y minus 1. And then the last thing I'm going to do is add that 1 over. So I'll have 1/12 x minus 2 squared plus 1. And just to make it just like what our eyes are used to, I'm putting the y on the other side. And now we see a parabola just like we had all over our final. And we would have said the vertex was 2, 1. Same vertex as what we had here, 2, 1. Notice on this one I'm changing both the signs. They're each with their own variable, and this one I'm changing the sign in the parentheses and not the other sign. And so again, it's going to be better for your kids if you tend to live in one of the two forms and always move to that form, because it gets confusing. When should I change the sign? When should I not change the sign? And if they get, in this one, it's kind of nice because both of the things have the same rule. You change the signs as you take them out. That matches what they do with the circle, where they change the signs as they take them out. So it's very consistent with the whole chapter. But if you are really wanting to live in this form, you can, and I would just live there all the time so that your students, whenever they're deciding what the vertex is, they're deciding from the same spot. So that if I was going to do this problem from this form, when I wanted the width, if I was very interested in using vertex or descriptive form, when I wanted the width, I would say that the width is the reciprocal of that. The width is 4c, and that is the reciprocal of that, so that's 12. I use the reciprocal. And from there I would still get c as 3, and my vertex would be very much like what we did earlier in the year, 2, 1, and that would be fine. Now, it will seem a little strange when you're solving for one that is an x equals, because that's a little different than what we did before, and the students typically will put these numbers in the wrong spot when they're in vertex form. They will not make that mistake so much in this form because the x is going to go with the x and the y is going to go with the y. They'll still make it some. And so let's just look at a homework problem or two so you can see how that's going to go. I'm going to move that and pull a homework in instead. So this is the homework overall. There are problems in each form, so whichever form you're emphasizing, you would have the kids move to that form. There's 6 of them. Some are sideways, some are up and down, some are facing to the left, some are facing to the right. And then there's 3 where they have to get the equation. And so I encourage you to work through and really see what your kids are going to be doing before you assign it, so that you make sure that you're comfortable with the form you're giving. Actually, I want to start with this one. So here's another one where x is squared. That's our normal situation. So let's do one where y is squared, because that's a little different. And if I was doing this problem, I wouldn't be very comfortable with this form. So I would change it into this form. But if you normally live in vertex form, then you would, the hard spot right here would be that you would need to get your students to name the vertex correctly. And so the vertex in this case is -4. That sign is not changed, but that's the x value. And then 2, that's the y value. Different than how we did before. So see, if you're living in this form because you think it's, oh, everything's going to be the same as you did before, it's not really the same when you get to non-function parabolas, sideways parabolas. And so anyway, I want to just warn you of that. Now what I'm going to do is I'm going to rearrange it because I am going to live in focal width form. So that means I want to get the squared piece by itself. So the first thing I'm going to do is add the 4 over, and I'll have x plus 4 equals 1/2 y minus 2 squared, and then I'm going to multiply both sides by 2, and because I'm talking to a bunch of teachers, I'm going to do that magically like this, and then I'm going to just put the squared piece over here because that's what I'm used to, and that would be my focal width form. I think I would like to add to this worksheet a spot for them to write the vertex, but you may or may not see it like that. We'll see if that gets changed or if it's already been run off by your team. So the vertex would be, I'm going to change the sign on both of these, -4, 2. Notice that's the same we got here. I just didn't have to think quite so hard when it's in this form. Now I'm going to go ahead and put that vertex on here, -4, 2. And operating entirely from the graph makes finding the focus in the Directrix easy. I don't need to write out formulas for the focus in the Directrix like you see sometimes in old Algebra 2 books. I can just actually use that. I know that 4c is the width of the parabola, and that's this 2, which makes c 1/2. And so from this vertex, I am going to think about if I'm going to go up and down or sideways. Let's see, y is squared. That's not normal. So y is squared is going to be one of these. Since the 2 is positive, I'm going to go positive 1/2 to get to my focus. And I'm going to go negative 1/2 to get to my Directrix. And so my focus looks to be -3 1/2, 2. And my Directrix looks to be x equals -4 1/2. I'm sorry, -4.5, -4 1/2. All right, and focal chord endpoints. Now the width of the entire parabola is 2 at the focus, so it means I'm going to need to go up 1 and down 1. So from this focus, I'll go up 1, and I'll have right there, down 1, and I'll have right here, and that will be my parabola. Just to let you know that sometimes all this talk about width confuses a weaker student, and they think it has to be too wide everywhere, and I'll see a graph that looks like this, and they just stay at too wide the whole way. So you want to remind them that parabolas will curve outward. That's just the width at the focus. It's not the width of the whole way. Our focal chord endpoints then were at the same spot as the focus, so it was -3.53 and -3.51. Notice the focus and the focal chord endpoints all have one number in common because they're just moving up and down. Only the y is changing there. Okay, so that's how that's going to work. This one, you might like to do an example like this or have them get to this one in class because there's nothing in the parentheses. This is in the form that I prefer, so I should be able to just look at it and see my vertex,